Okay, if we just start by considering this quadratic, alpha or x minus alpha multiplied by x minus beta, you know that that quadratic is going to look like that, and that these roots, as we call them, are going to be at alpha and beta. If we assume alpha is smaller than beta, it doesn't really matter. So these two values give you the root. So that's minus alpha, the root's alpha. That's minus beta, the root's beta. So if we assume that, we're told that alpha and beta are the roots of our equation in this question. Let's assume that we can write this as alpha, x minus alpha times x minus beta. Okay, so this is the equation you're given. If we're assuming, or we're told that the roots are alpha and beta, then we know that that can be written as x minus alpha multiplied by x minus beta, say. So, if it can be written like that, and think about how we factorise, what we can say is that the multiplication of these two values, here and here, must give you this value at the end. So they're always times together to get this one at the end. So minus alpha multiplied by minus beta must give us an answer of k minus 1. Minus alpha times minus beta, two negatives make a positive, so we're just finding out that alpha beta is k minus 1. If you look at the middle term, we know that if we have these two roots, that their sum, so if we add them together, we get this middle coefficient. So we can say from that, I know that minus alpha, if I add minus beta, that's just the same as taking minus beta, or taking beta, equals minus k. Or, if I just multiply everything by minus 1, alpha plus beta must give me an answer of k. Okay, if we do a quick rearranging of this, hopefully you'll agree that if I rearrange that, I'll get that beta, therefore, must be the same as k minus alpha. So all I'm going to do is into this equation, where there's a beta, I'm going to put k minus alpha. So it'll be alpha times k minus alpha equals k minus 1. And then I'm going to multiply that out, and I'm going to get alpha k minus alpha squared equals k minus 1. Or I could have that alpha squared must be equal to alpha k minus k plus 1, if I do a rearranging of that. And hopefully, if you try the same with changing this, so if instead you write this as alpha equals k minus beta and do the substitution, you'll also get the equation beta squared equals beta k minus k plus 1. So those are the two equations that we're going to use next. So in the question you're told that alpha squared plus beta squared equals 17. So you're given that information in the question. And if you just go back to what we've just done, we substitute in, we worked out what alpha squared was. So if you substitute in that alpha squared was alpha k plus, minus, my mistake, it's alpha k minus k plus 1, and the beta is beta k minus k plus 1 equals 17. And then if we multiply out, we're going to get alpha k plus beta k minus k minus k, we're going to get minus 2k plus 2 equals 17. And if you kind of spot here what we've got, this bit, I'm going to have k times alpha plus beta. This is going to be minus 2k minus 15 equals 0. And this is the trick. Back at the start, one of the first equations we wrote was that alpha plus beta was equal to k. So this can now be replaced with k. So k times k, we're going to get k squared minus 2k minus 15 equals 0. And that will factorise into k minus 5, k plus 3 equals 0. So your final solution is either k equals 5 or k equals minus 3. Hope that helps.